Hey everyone, hope you're doing well today. In this video, I'm going to be going over an answer key for Unit 4 quiz review. So we're mainly focusing on the topics of one-step equations and inequalities. So let's jump right into it. So for this first section here, we're going to go ahead and state the properties of equality. So it says properties of equality and the identity property. So remember, there are 4 properties of equality. There's adding, subtracting, multiplying, and dividing. Those are the 4 properties of equality. And then there's also the identity property. So that's really just when you get 1 through multiplication or division, or you get 0 through addition or subtraction. We don't actually have to solve these equations. So it says do not need to solve these equations. We're just going to go ahead and write the property. So for number 1, let's take a peek. If we were going to solve this equation of x plus 42 equals 58, what would we have to do to both sides? We would have to subtract both sides by 42, right? So what would you have to write here for the property? You would just say use a subtraction property of equality. And then once you subtract, what are you going to get for the identity property? You're just going to get you're going to get 0, right? So if you're going to get 0, that's the addition property of equality. Identity property of addition. Okay, so I'm just going to write addition identity property. That's perfectly fine. Okay. For number 2, we have the equation 47 is equal to y minus 12. So how would you solve this equation? Well, you would add 12 to both sides. So we would use the addition property of equality. That would be the property we would use to solve for y. Once we do that, though, we'll have y plus 0. So again, just like number 1, we're going to get the addition identity property, or identity property of addition. Okay, that's all we got to do. These are the 2 properties that allow us to solve this equation. Okay. For number 3, we have 3c equals 48. So what would we do if we were solving this equation? This means 3 times c equals 48. So we would divide both sides by 3. So we would use the division property of equality to solve this. We would divide both sides by 3. Doing so, though, we'd end up with 1c, right? And we can drop the 1 by using the multiplication property of equality. Identity property. Get a little confused with myself. Okay, cool. So again, we're using one property equality for each one, and then the identity property for each one. Okay. For this next one, we have 14 is equal to p divided by 5. So if we were going to solve this, we would multiply both sides by 5. So I'm going to write multiplication property of equality, right? We would multiply both sides by 5. Then we would get 1p on the right side, which just simplifies down to p. So if we do that, that's going to be the multiplication identity property again. Again, there's only 2 identity properties, and there's 4 properties of equality. So just make sure we know our properties. That's what we're reviewing for these first 4 questions. Okay, moving on. This next section here, we're going to solve the following equations. Okay, so we have to solve them this time. We have to make sure we use the properties of equality, which we just talked about, and whichever identity property that we're supposed to use. So we don't have to label them, but we do have to use them. So for this first question here, what would we say? Well, I would subtract 13 on the left and subtract 13 on the right. That is the subtraction property of equality, right? And if we do that, we're going to get x plus 0, and that's going to be equal to 35. Okay? If we go ahead and drop that 0, though, and we just write that x is equal to 35, then we've just used the identity property of addition by dropping that 0. So writing all this shows that we've used 2 properties here. Okay? Okay, moving on to this next one. We have y minus 27 equals 54. What are we going to do to solve this? Well, we see subtraction, so we're going to use addition. We're going to add 27 to both sides here. If we add 27, we're going to get y plus 0, okay, is equal to, I think that's 81. All right, and then we can drop that 0 and just say y is equal to 81 using the identity property of addition. Adding 0 can be done away with. Okay. Moving on to number 7, we have 3m equals 42, which is 3 times m equals 42. So the property we're going to use here is division property of equality. 3 divided by 3 is 1, so we have 1m equals, and then 42 divided by 3 is going to be 14. And then since 1 times m is just m, we can use the identity property of multiplication and drop that 1 and write m is equal to 14. Okay. Number 8, I'm just going to rewrite this because there's never enough room for these equations on the left side, okay? And so this says w divided by 4 is equal to 24. what's the inverse of dividing by 4? It's going to be multiplying by 4. So I'm going to multiply both sides by 4 using the multiplication property of equality. Then if we have 4 over 4 on the left side, that's going to be 1w. And on the right side, 24 times 4 is going to be 96. We can drop the 1 and say w equals 96 using the multiplication identity property. Cool. So those are these 4 equations here, and this is all the correct work shown using the properties of equality and the identity property. Again, when we talk about the identity property, which is right over here, the goal is really this getting the 0. So you can see we have this plus 0, identity, this 1 times m, identity, plus 0 again, identity, and then times 1, identity. So anytime you're multiplying by 1 or adding 0, we're using the identity property. Okay, moving on here, we have a few more to try using these properties of equality. Okay, so if we have E minus $12.45, we spend some money, we're end up with $37.95. We can go ahead and add $12.45 to the left side and add $12.45 to the right side. And let's see what's going to happen if we do that. Well, on the left side, we're going to get E plus 0. Okay, and on the right side, what are we going to end up with here? I think that's going to be $50.40. Okay, $50.40. And then we can drop the 0 using the identity property and say E is equal to $50.40. That would be the solution here. Cool. Alrighty, for number 10, we have $42.43 is equal to H plus this $18.98. So what would we do here? Well, it's okay that the H is on the right side. Don't let that bother you too much. If it does, you can always rearrange it and just put it on the other side. But let's see what we got here. I'm going to use a subtraction property of equality and take away 1898 from the right side, and then take away this 1898 from the left side. Okay, so we got to do both the same thing on both sides. That's the property of equality. On the left side, if you do the 4243 and you take away the 1898, that should equal, if I'm not mistaken here, $23.45, and that's going to be equal to H plus 0 on the right side. And then you can drop the 0 using the identity property and say $23.45 is equal to H. I like turning it around at the end, but that's optional. Okay, I just like my variable on the left side. Cool, that would be the value of H here. All right, moving on, let's see what we got next. For number 11, we have 32 is equal to 4/3 times K. So what are we going to do to both sides to get K alone? We're going to divide by 4/3 using the division property of equality. Okay, so on the left side, we have 32, maybe I'll write this on the side. We have 32 divided by 4/3, right? And if we're dividing fractions, keep in mind we have to keep the first one, so it's 32 over 1. We're going to change this to multiplication and then reciprocate or flip the second fraction. We can cross cancel here. That'll be a 1 and that'll be an 8, since 8 times 4 is 32. And then 8 times 3 is going to be 24 over 1 times 1, which is 1. And so if you take 32 and you divide it by 4/3, that's equal to 24. So on the left side, we're going to get 24. And on the right side, what's 4/3 divided by 4/3? Well, that's just 1, so we have 1K. And then we can go ahead and drop the 1 using the identity property and say 24 is equal to K. And I just like turning it around and saying K is equal to 24. Alrighty, nice. Next one here for number 12. Again, for these ones, I know I'm going to run out of space, so I'm just going to rewrite the problem here. So something is split 6 ways, and it's going to be $34.25 for each of the ways, I guess. If you're splitting a bill 6 ways, each person pays $34.25. How would you solve this? Well, instead of dividing by 6, we have to multiply both sides by 6. That will cross cancel the 6's. 6 over 6 on the left side is going to be 1, so we have 1p. And on the right side, if you have $34.25 and you multiply that by 6, that's going to be a total of $205.50. And then we can go ahead and drop the 1 using the identity property of multiplication and say P is equal to $205.50. Cool. So that would be the answer for number 12. All right, so there you have some equations dealing with just using the properties of equality and solving for the unknown variable, okay? Alrighty, so for this next section, we're going to go ahead and write an equation that's going to be best representing each of these situations, okay? Then we're going to use the properties of equality and the identity property to solve each of them, okay? So let's see here. After spending $24.87, so hold on a second. We're spending money, so we're subtracting, so go ahead and write that down. $24.87. So we're spending money. We know that Audrey is going to have $38.48 left. Okay, so after spending money, we're going to end up with $38.48. So that's going to go by itself at the end of the equation. The question is determine how much money that Audrey had before spending the money. So we need to come up with a variable here. So I'm going to use A for Audrey. I'm going to put A over here. That's how much money she had before spending the money. And so here is our algebraic equation here, okay? Now, how would we solve this? Well, if we would see subtraction, we're going to go ahead and use the opposite and use the addition property of equality. And we're going to add $24.87. We're like unspending the money here, okay? Going backwards. So on the left side, we're going to have A plus 0. That's using the identity property, right? Because we know that's equal to 0. And then $38.48 on the right side plus $24.87 should equal a total of $63.35. And that should make sense that this value is higher. Pencil's being a little weird here because we should have more money if we didn't spend this money, right? We can drop the 0 and say A equals $63.35. That's the solution. What does that mean? We can say in conclusion here that Audrey must have had $63.35 before, I guess, shopping, maybe. She shopped for something. So maybe a short sentence just like that. So she must have had that much money before she spent the $24.87, okay? Number 14, let's try another one here. Giselle bought 7 packs of the same candy. Okay, maybe we can use the variable C here. So we're buying 7 of the same candy. So 7 times C is equal to, and we know the total cost here is going to be $62.58. So 7 of the same thing costs the same, okay. And so we have to determine the cost of 1 pack of that candy. Okay. Easy enough here, right? We just have to figure out what 1 costs. We're going to divide by 7 and divide by 7. So what's 7 divided by 7? That's 1 candy. That's what the 1 represents. And then 62.58. If we go ahead and divide that, that's going to end up being, let's see, $62.58. If we divide that by 7, that's going to be $8.94 for 1. So we can drop the 1 using the identity property and say C equals $8.94. And what's our conclusion here? We can say that Giselle spent $8.94 per candy. That's all. Okay, that's the cost of 1 pack. Let's try some more here. Number 15, Hanson lost 3/5 of his HP. 3/5 of his HP. Really important to remember that of in math means multiplication, okay? Whoopsies, don't know what's going on there. Of means multiplication, okay? So he lost 3/5 of his HP or health points in a video game. He now has 140 HP left, okay? This is how much he has now. The question is, how much did he have before? Okay, so if he lost all of his, not all of his HP, if he lost 3/5 of it, keep in mind here, if he had all of his HP, that would be 5/5, right? He'd be completely full health, but he lost 3/5 of his HP. So how much HP does he have left? Well, if he lost 3/5, he must have 2/5 left. I'm going to write that again, 2/5 left. Okay. So the question is, well, how much does he have left? Well, we know here that he has 140 left, right? 140 HP. So let me see if I can rewrite this real quick because this is a little bit... So a little strange here. What's going on here? Let's go ahead and say that was what he had left. Maybe it'll not be temperamental. This is what he had left as well. So 2/5 of his health must be equal to 140, which is what he has now. So 2/5, let's go ahead and write that down. 2/5 of his health, so it's times H, is equal to this 140. Okay? what are we going to do here to solve this equation? Well, on the left side here, we're going to divide by 2/5. My pen wants to cooperate here. What's 2/5 divided by 2/5 on the left side? That's going to be 1h, or all of his health. And on the right side, we have this 140 divided by this 2/5, right? So it's important to kind of write it just like that, 140 over 1. Keep that. Let me see if I can write that a little bit more clear. Pen's acting up here. Keep, and then change, and then flip. And we can see some cross-canceling going on here. And so if we multiply that out, let's see, that's going to be 70 times 5 is 350 over 1, which is just equal to 350. So all of his health must have been 350. So his health was 350 before he lost that health. Okay, so we can say here that Hansen had 350 HP at full health. Cool, that's what we just found out there. Okay, all right, moving on. Number 16, Celine went out to eat with 5 of her friends. Okay, so Celine and 5 friends, that's a total of how many people? That's 6 people. I'm just gonna write that down. There's 6 total people here. And say if each of them paid here $12.48, that's for each person after splitting the bill evenly, so that's sharing it. What was the total bill? So we have to figure out how much there was before. Okay, so the total bill, maybe I'm going to use the variable b for the total bill, and we're splitting it 6 ways. Celine and 5 people, that's 6 total people, and each person is spending $12.48. Okay, so on the left side here, we're going to multiply by 6, and on the right side, we're also going to multiply by 6. So on the left, those 6's will cross cancel, so you get one total bill is equal to, let's see, what is $12.48 times 6? That should be equal to $74.88. So we know the bill, the total bill, is equal to $74.88 before they split it 6 ways. So we can say the total bill was $74.88. Okay, that was before they split it. Alrighty, let's move on here. Number 17, in these problems, we're going to solve these equations. We're going to find the variable, and we're going to make sure to combine like terms first. Okay, so on the left side of the equation here, notice what we have. We have this 4x plus 2x, and those are like terms, so they can be combined if they're on the same side. So 4 plus 2 is 6. We can add those coefficients. So we have 6x equals 24. Now it's just a one-step equation. We're going to divide by 6 and divide by 6. We're going to get 1x is equal to 4, and we can write x is equal to 4. That's it, okay? For number 18, look on the right side. We have this y plus 6y, but keep in mind that this is 1y plus 6y, right? There's that coefficient. So if we combine 1y plus 6y, that's going to equal 7y. And then what we can do is use the division property of equality and divide both sides by 7. We get 5 is equal to 1y. And then we can drop the 1 and say 5 is equal to y. And I'm just going to turn it around and say y is equal to 5. Cool. Moving on to number 19, we have these like terms, these constants on the left side. So we have h plus, and then what's 5 plus 13? That's 18 is equal to 27. And then we're going to go ahead and use the subtraction property of equality and subtract 18 from both sides. If we do that, we'll get h plus 0 is equal to 9. Then we can drop the 0 and say h is equal to 9. Just like that, okay? For the next one, number 20, on the left side, we can combine these constants. What's 18 plus 31? That's going to be 49. So 49 is equal to, and on the right side, we can combine these like terms. What's 3 plus 14? Those coefficients add up to 17x, right? And then let's see what we're going to do. We're going to divide both sides by 17. Notice this isn't going to come out nicely because 17 doesn't go into 49. But what we can do is write, how many times does 49 divide 17? Does it fit in 2 times? Yes, 3 times, almost 3 times. So this is going to be 2, I believe, and 15/17. So again, when you're dividing, you can just turn it into a mixed number, and that's perfectly okay. That's equal to 1x. So 2 and 15/17 is equal to x. I'm just going to turn this around and say x equals 2 and 15/17. So you can leave it as a mixed number or an improper fraction, but just to practice that fraction work, that's the exact value that makes this equation true. Okay, almost 3 times, but not quite. All right, moving on. For these next few, we're switching from equations to inequalities, right? This is where we have the less than, greater than stuff. And then so we're going to graph, and then we're going to write 3 possible solutions for each of these inequalities. Okay. For 21, we have x is greater than 8. So let's see how we're going to write this. I'm going to go ahead and put 8 in the middle here. And then I guess we could put 9, 10, 11, and then 7, 6, 5. And we're going to put an open circle on 8 because it can't equal 8. And we're saying x is greater than 8. So that's going this way. So what are some values that x could be? X could equal 9, 10, or 11. Okay. I don't know what's going on over there. I'm just going to get rid of it. But these are just 3 of the possible solutions. Okay. Moving on here, for number 22, this says f is less than 14. So I'm going to put 14 in the middle. We'll put 15, 16, 17, 13, 12, 11. Okay, so if f has to be less than 14, it can't equal 14, so put an open circle. And let's go to the left. What are some values that make this true? Well, it's not x here, it's f. F could equal 13 or 12 or 11 and anything smaller. Okay, just can't equal 14. For 23 here, we have w is less than or equal to 42, so let me put 42 in the middle. 42, 43, 44, 45. I could put 41, 40, and 39. You can do skip by different numbers if you'd like. W is less than or equal to 42. So we're going to fill in this circle, closed circle, and go to the left. And so what numbers could this be? Well, W could equal 42 or 41 or 40, and so on and so forth. Okay. For this next one, we have Q is greater than or equal to 95. So that's our number in the middle. 95, 96, 97, 98. We'll put 94, 93, and 92 here. Q is allowed to equal 95, so I'm going to put a closed circle, and then we're going to draw an arrow going to the right. What are some values that make this true? Well, Q could be 95. Could also be 96, could also be 97, as well as anything greater. All right, so there are some inequalities with some graphs. Moving on, for this next section, we're going to write an inequality. For each scenario, we're going to graph it, and then we're going to write 3 possible solutions. So we're doing a little bit more here, okay? Ms. Jaeger eats at least, what does that symbol mean? That's greater than or equal to. She eats at least 48 waffles per hour when she's not at school. So I'm going to use W for waffles here. So Ms. Jaeger eats at least 48 waffles when she's not at school. So that would be the inequality, okay? And then we have to graph it and then write 3 possible solutions. So here's the graph. I'm not going to be too detailed with it here. This is going down forever. This is going up forever. 48 is going to go in the middle. I'm going to put 49 and 50, just 2 numbers to the left. And put 47 and then 46. Whoops, not negative 46, just a normal 46. And let's see, we're going to put a closed circle on 48 because Miss Jaeger can eat 48 waffles or more. So that's this way. What could this equal? Well, she could have had 48 waffles, or she could have had 49 waffles, or she could have had 50 waffles. But there's many other possibilities, okay? For this next one, Mr. Lee makes more than 5 pizzas per month, so that's this greater than symbol. I'm going to use the variable p for the number of pizzas. P is greater than 5. Okay, making a number line here. Go ahead, put negative infinity, positive infinity. I'll put 5, 6, and 7, and I'll go 4 and 3. Go ahead and put an open circle. So I say Mr. Lee makes more than 5 pizzas, so at least we have to make sure we're going in the right direction. It's not 5, but it could be 5 1/4, 5 1/2. Anything bigger than 5 would make this true. So Mr. Lee could make 5 1/2 pizzas. Could make 6 pizzas. Could make 100 pizzas. Those are just three possible numbers. Okay. Number 27, Mr. Yeager works out for a maximum of 45 minutes each morning. So maximum actually means less than or equal to, right? So if you have a limit of a maximum, then you can be anything less than that. So Mr. Yeager working out, maybe I'll use E for exercising. So E has to be less than or equal to 45. Okay, she doesn't have enough time to work out longer. So that's the max she can do each morning because got to wake up nice and early. And so here's a number line, negative infinity, positive infinity. Let's put 45 here, 46, 47. Let's put 44 and 43. So E has to be less than or equal to 45. Let's go ahead and put that right in the middle and go down. Okay, she can work out for less than that. So what are some numbers she could hit here? She could do for 45 minutes. She could do for 40 minutes. She could do for 35 minutes. Those are all possible. Number 28, Mr. Lee makes less than, oh, that's a key word, makes less than $65.48 per month making YouTube videos. So I'm going to use Y for maybe the YouTube videos. So making less than $65.48. Okay. What about a graph here? For a graph, let's make this a little longer because I got to put some decimals in. So I'll go down forever. We'll go up forever. We'll put 65.48 in the middle, 66.48, and 67.48. So we'll just go up $1, and those 64.48, and then 63.48. And Mr. Lee makes less than 65.48, so we're going to go to the left here, anything less than that. What are some values that could be true? Well, Mr. Lee could make $65.47. That's possible. Could make $3.45. Could also make $1.10, but that would be sad. Those are just three possibilities. Okay, 29. The area of a rectangular play area. Okay, so rectangles, let's think about what kind of formula we have for area. If I had to find the area of this rectangle, this would be the length, this would be the width. Let's see, area is equal to length times width. Just keep that in mind, okay? Must be greater than, that's a key word, must be greater than, we'll put an inequality, and the area has to be greater than this 48 square meters, so the area must be greater than 48 meters squared, okay? If the length of the play area is 6 meters, the length is 6, and write that down, the length is 6 meters. The question is, what are all the possible widths of the play area, right? So how wide could it possibly be if the area has to be greater than 48? Okay, well, let's think about this. If we know here that length times width, oh my goodness. If we know here that length times width is equal to area, right? Area is equal to length times width, so length times width equals area. We know the length is going to be 6, so 6 times something has to be greater than 48, right? Actually, yeah, I think this is right? The length times width has to be bigger than 48 for the area. So 6 times W, that's really just 6W, is greater than 48. Well, it kind of looks like a one-step equation, but it's an inequality, so it's actually a one-step inequality. So if we know 6 times 8 is 48, and the area has to be bigger than 48, then we actually know here that if we were to divide both sides by 6, then we know the width here has to be greater than 8, right? If 6 times 8 is 48, then 6 times anything bigger than 8 would be bigger than 48. So we're going to conclude here that the width must be, not at least, but greater than 8 meters. That's what this means here, okay? So if we had a rectangle that looked like this, where we had, let's see, if we had 6 was the length, right? If we said this was 6, then as long as this was like 9, then 6 times 9, the area here would be 54, and that would be greater than the 48, right? You could also have something like, I know I'm not drawing these to scale, so if that's bothering you, sorry. If I say 6 and 10, which is also bigger than 8, then this area then would be 60. But you can see as we keep going higher and higher for this other number here, for the width, then the area is gonna keep getting bigger as well here, okay? If I chose something smaller than 8, like 7, then our area would not be big enough. All right, moving on, last problem. So Noah here tutors elementary school children in math and makes $42 per hour, okay? Maybe we can use the variable h to represent the number of hours he's tutoring for. The question is how many hours would he need to tutor to make more than, more than means greater than, more than this $300, okay? So he's tutoring for $24 an hour, so we can write 24h, and $24 per hour, and it's got to be greater than the $300. Okay, so let's see how many hours would he have to work so that he makes more than that. Well, if he makes $24 per 1 hour, maybe let's figure out how much he makes in 1 hour. So let's divide both sides by 24. So h has to be greater than, let's see what like 300 divided by 24 is. 300 divided by 24. I think that's going to end up being 12.5, right? And so if I asked you like how many total hours would he have to work to make more than $300, then, well, 12.5 exactly would make you $300, right? Because 12.5 times 24 equals 300. So he'd have to work for more than 12 and a half hours. Maybe if he gets paid by the hour, he definitely has to work 13 hours. But if he works by the half an hours, you know, if he works for 12 hours and 31 minutes, I don't know if someone's going to pay him for that extra minute, but technically he would be making more than $300. So here we have our h is greater than 12.5. So we know here that Noah needs to tutor for more than 12.5 hours. 12.5 hours won't be enough, but anything more than that would be. So that's our conclusion here, okay? So we need to graph anything here. I think in the directions to say graph as well, and then write 3 possibilities. Okay, so I didn't write 3 possibilities for the last one. So what are some possibilities here? We can say that the width, I think I said it could be 9. Maybe I did 2 of them. It could be 9, 10, or 11. Those are the possible widths for number 29. Forgot to do that, so just double checking. And then down here, how much could Noah tutor to actually make his profit here? Did I actually have to graph too? Oh my gosh, sorry about that. I didn't make a graph either for the last one. So what are the possible widths? Sorry, I'm a little bit all over the place for this last couple. Here's 8, here's 9, here's 10, here's 7, and here's 6. Okay, and so what could the widths be here? The width can't be 8, but it had to be anything bigger than 8, which makes sense because 9, 10, and 11 are all bigger than 8. Okay, for this one with Noah tutoring, let's show all the possible hours he could be tutoring here and then where the solution lies. So 12.5 is here, let's say 13 is here, and let's say 13.5. Under here we'll put 12, and then we'll put 11.5. So Noah's got to be tutoring for greater than 12.5 hours to make over $300, and that's going to go over here. So we can say here that the number of hours Noah can tutor here to make that amount of money could be something like 13 or 14 or 15. The more he works, the more money he's going to make. All right, there you have it. So just like that, we've gone through 30 different practice problems on basically the first half or so of Unit 4, which is just focusing on equations and inequalities. All right, so best of luck and study up.